We have a process called synthetic division that will allow you to perform a long division only if the divisor is in the form of x minus some number. So it can be x minus a negative number, or it can be x minus a positive number. There are instructions on how to perform synthetic division below, but I'm going to take us right to the example and perform this synthetic division. First thing that I want you to do is draw a two-sided box on the left upper side of your page, and then I want you to think about your divisor and what value of x would make that divisor equal to 0. If x minus 5 equals 0, then x is equal to 5. The next thing that we're going to do is we're going to take the coefficients of the dividend. That's the expression that's being divided, and we're going to write them right next to the box. So 3x to the third, negative 13x squared, leave a little space in between, negative 4x, and 2. So we're leaving out the variables, we're just writing the coefficients, and our terms need to be written in descending powers. So the cubic term first, the squared term second, and the linear term, or x to the 1 term, next, and constant term last. First thing you do in synthetic division is bring that first number down, which is 3. Then we're going to multiply 3 times 5 and get 15, and we're going to write it below the next number in the sequence. Then we're going to add that column, negative 13 plus 15 is positive 2, and then multiply by 5 again. So 2 times 5 is 10. Add that column, negative 4 plus 10 is 6, and then multiply by 5 again. 6 times 5 is 30, and then add that column. Our result is two-part. These numbers here, 3, 2, and 6, are the coefficients of the quotient, which is the result from the division, and then that 32 is the remainder. So when we write our result, it will be very similar to the kind of result we write from long division. In order to know what the first term represents, I would encourage you to look at the first term of the dividend divided by the first term of the divisor. And so 3x to the second power divided by x is 3x squared. That's going to be the first term of your quotient. So the 3 here represents 3x squared, and the 2 here represents another term, plus 2x, so we're descending in powers. The 6 represents the constant term 6, and then just like in long division, we're going to express the rest as plus the remainder divided by the divisor. So that's going to be the result of that synthetic division. Once we learn how to perform synthetic division automatically, it will go very quickly. Let's practice with the next division. What we'll notice here is that we have some terms out of order. So I'm going to rewrite the terms in order. So the division is first term 6x cubed plus second term 5x squared. And think about what term ought to come next. We ought to have something times x. However, there is no term that multiplies by x. So I'm going to write a placeholder of 0x, and then plus 2, and then finally divided by x plus 2. So you may take some time to rewrite the terms in descending powers, including putting 0 placeholders. I'm going to write that box out to the left, and then I'm going to think about what number would make the divisor equal to 0 if we replace x with that number, and that number would be negative 2, since x plus 2 equals 0 when x is equal to negative 2. Next to the box here, I'm going to write the coefficients of this dividend, which are 6, 5, 0, and 2. I'm going to skip a line, and then I'm going to bring down that 6. 6 times negative 2 is negative 12. 5 plus negative 12 is negative 7. Negative 7 times 2 is 14. 0 plus 14 is 14. 14 times negative 2 is negative 28. and 2 plus negative 28 is negative 26. So when we write our result, here are our coefficients for the quotient, and here's our remainder. So the result will be 6x squared minus 7x plus 14 plus the remainder, which is negative 26, over the divisor, which is x plus 2. All right, pause the video while you try the next one on your own. You should have gotten a result of x plus 6 plus 16 over x minus 3. In example 5, we have a working backwards sort of a problem. When f of x is divided by x minus 3, the result is x squared plus 2x minus 5 plus 7 over x minus 3. Our job is to find f of x. So what I'm going to do is just translate what was stated here. When f of x is divided by 3, so that would be f of x divided by x minus 3. The result is, there's our equal sign, x squared plus 2x minus 5 plus 7 divided by x minus 3. In order to solve for f of x, we need to multiply both sides of this equation by x minus 3. I've distributed that multiplication to each term in this equation, and now we're going to do some canceling or reducing. So x minus 3 times 1 over x minus 3 is 1, so those are going to divide out or result in 1. Each division results in 1 for those. And now we can simplify and get what's left on each side of the equation. So on the left side of the equation, f of x. On the right side, distributing, we have x squared times x minus 3, which is x cubed minus 3x squared. Now for the next multiplication, 2x times x minus 3 is 2x squared minus 6x. And for the next multiplication, negative 5 times x minus 3 is negative 5x plus 15. And for our last multiplication, since the x minus 3 factors canceled, we have 7 left. Lastly, I'm going to combine like terms of this polynomial in order to get the polynomial in standard form. So f of x is equal to x cubed minus x squared minus 11x plus 22. In example 6, we are dividing the function g of x by x plus 1, and then we're going to use the result to write g of x in what we call partially factored form. Let me explain what partially factored form means. So for instance, if I asked to factor 18 and I factored it into 6 times 3, we might say that that is partially factored because you can fully factor by factoring the 6 once again. So our fully factored form would be 3 squared times 2. All right, that's as relates to numbers. And now let's relate this same idea to this problem where we're asked to divide. And dividing is something that has some parallels with division. We need to, in order to factor, we have to divide. So our job here is to divide by x plus 1, so I'm going to put the 0 of x plus 1 in the box. If x plus 1 is equal to 0, then x is negative 1. And then list the coefficients of g of x, which are 1 for the x cubed term, negative 6 for the x squared term, 3 for the x term, and 10 for the constant term. Skip a line, bring down that 1. 1 times negative 1 is negative 1. Add that column, that gives us negative 7. Negative 7 times negative 1 is 7. Add that column, we get 10. And then 10 times negative 1 is negative 10. And our last entry here is 0 when we add that column. Remember, these are going to be our coefficients of the quotient, and we have a 0 remainder, which means we have no fractional part for our result. So what I'm going to do is I'm going to write that division out just as we stated it. G of x, we took it and we divided it by x plus 1, and the result was x squared minus 7x plus 10. In order to write g of x in partially factored form, I can multiply both sides by x plus 1, and I'll get x squared plus 7x plus 10 times x plus 1. That's a partially factored form And if I wanted to, I could actually go one step further and write this in fully factored form, even though that wasn't asked. X squared minus 7x plus 10 factors into x minus 2 times x minus 5, and then I'll bring down that x plus 1 factor, and here's our fully factored form. All right, in 7, we have a function p of x, and we're asked to find the value of p of 2. In order to find a function value, we take and replace all of the x's with 2. So p of 2 is 2 squared plus 3 times 2 plus 1. Now we have some arithmetic to perform. That's 4 plus 6 plus 1, which means that p of 2 is equal to 11. In part B, a seemingly unrelated process, divide p of x by x minus 2. So if I'm dividing by x minus 2 using synthetic division, I'm going to put the 0 of the divisor, which is 2, in that box, and then the coefficients of the dividend, 1, 3, and 1, right next to it. Skip a line, bring that 1 down, 1 times 2 is 2, add that column, 3 plus 2 is 5, and then 5 times 2 is 10, and add that column and we get 11. And so the result here is the coefficients of the quotient, x plus 5 plus 11 divided by x minus 2. Now when we look at these two seemingly unrelated questions, what we're going to notice is that 11 is the value of p of 2, and 11 is also the remainder in the division. So that brings us to something called the remainder theorem. The remainder theorem is stated as when the polynomial p of x is divided by x minus c, where c is some number, a constant, then the remainder of the division has the same value as p of c. So this is going to be important to us. If we want to use synthetic division to find f of 5/2, that's going to be the same thing as the remainder when the function f of x is divided by x minus 5/2. So if I'm dividing by x minus 5/2, I'm going to put the 0 of the divisor, which is 5/2, in that box, skip a line, and draw that line below. Coefficients of the dividend go right next to that box, 2 for the x cubed term, negative 11 for the x squared term, 17 for the x term, and minus 1 for the constant. Let's bring down the 2. 2 times 5/2 is 5. Add that column, that gives us negative 6. Negative 6 times 5/2 is negative 15. Add that column and that gives us 2. 2 times 5/2 is 5, and that gives us a remainder of 4. By synthetic division, the remainder is the same thing as the function value, so that means that f of 5/2 is equal to 4. Let's pause the video here and try the next one on your own. Okay, you should have gotten g of negative 6 is equal to 63. All right, let's move on to example 9. In example 9, find the remainder when you divide by x plus 1. Which method should we use? Where we're going to actually do a division, or are we just going to use the remainder theorem? Well, if we do division, don't write this down, I would have negative 1 in the little box as the 0 of the divisor, and I would have 1 for the x to the 48th term as my coefficient. Then I'd have 0 for the x to the 47th term, 0 for the x to the 46th term, 0 for the x to the 45th term. You see where this is going. I'm going to need a much wider paper in order to be able to perform this entire division, and I'm probably going to give up at some point and say I'd really rather not. But what we can do is we can say that this function, let's call it f of x, this function is the function that when I replace x with negative 1 will give me the remainder for this division. So f of negative 1 is equal to that remainder by the remainder theorem, and f of negative 1 is negative 1 to the 48th power minus 3 times negative 1 to the 7th power plus 4 times negative 1 to the 3rd power minus 2. What we know about negative 1 raised to a power is that it's positive 1 when the exponent is even, and negative 1 when the exponent is odd. So now if I perform the operations here, we're going to get 1 plus 3 is 4, minus 4 is 0, minus 2 is negative 2. So our remainder is equal to negative 2. In example 10, we're finding the value of k such that when I divide this polynomial by x plus 2, the remainder is 7. There are actually two ways to do this one. Number one, what we can do is we can actually just do the division. Since we're dividing by x plus 2, we put a negative 2 in the box as the 0 of the divisor, and then our coefficients, the coefficient of the x cubed term is 1. The coefficient of the x squared term is k. I'm going to space mine out a little bit more because you'll see in a moment that we'll need that space. And the coefficient of the x term is 3, and the coefficient of the x to the 0 term, or the constant term, is 1. So I'm going to bring down my 1. 1 times negative 2 is negative 2. When we add this column, we get k minus 2. Now we're going to have to multiply k minus 2 times negative 2. Distributing the multiplication, that gives negative 2k plus 4. Adding that column, we get negative 2k plus 7. That, in turn, has to still be multiplied by negative 2 again, so that's going to give us 4k minus 14, and then adding that column we get 4k minus 13. Remember that this thing, this result right here, is the remainder, and we were told that we want for the remainder to be equal to 7, so I'm going to take that remainder here and I'm going to set it equal to 7 and then solve for k, and that will give us 4 times k is equal to 20, and k is equal to 5 is the answer to the question. There is a second way that we can work this one, and that way would be using the remainder theorem. You might like this way a little bit better. So if I use the remainder theorem, the remainder when dividing by x plus 2 is the same as the value of this polynomial when x is replaced by negative 2. So negative 2 cubed plus k times negative 2 squared plus 3 times negative 2 plus 1. Let's simplify this. Negative 2 cubed is negative 8, and negative 2 squared is 4, so the second term is 4 times k, and 3 times negative 2 is negative 6, and now we bring down that plus 1. This simplifies to 4k minus 13. That's our remainder using the remainder theorem, and we can again set this remainder equal to 7, and when we solve we're going to get the same result that we got the last time. So there are really two different ways that this problem can be worked. Pick which way makes the most sense to you or it seems easiest.